Hi, welcome to my channel, Programming Knowledge by Jagadish. I am Jagadish M, working as Associate Professor. Now, in this video, we are going to discuss about a data structure stack. What actually a stack means, in which manner we are going to perform the operations on stack, and what actually the basic operations that we are going to perform in stack is going to specify by this particular video. Now, first of all, what actually stack means? Stack is nothing but a linear data structure, and it follows a principle named as last in, first out, which indicates the last element is going to delete first. Whatever we insert a element recently or lastly, that element is going to delete first or immediately. So when we just go to work with a stack data structure, we just go to specify the insertions and deletions are going to take place at only one end. We can call that particular one is nothing but top of the stack. If you are inserting an element into a stack, we insert from the top of the stack. Similarly, if you want to delete the element from the stack, we delete the element from the top of the stack. So, in order to perform the operations on stack, stack maintains a variable, a special variable called as top. Whatever the operations that you perform on stack, those operations are based on the value of top only. If you want to insert a value into a stack, or if you want to delete a value from a stack, the insertions and the deletions are done based on the value of the stack, the value of the top only. By means of this particular one, we are going to insert or delete the values into the stack. And then in the stack, whatever we perform the operations, those elements are removed in reverse order. If you insert any value or if you insert a set of values, those values are removed in a reverse. As we already know, whatever the element that we inserted, that value is going to delete first. So that is what actually the LIFO principle means. Now, what actually the operations that we perform on the stack? See, here we just go to explain with an example. And those example is nothing but illustrated here, which is nothing but inserting the values ABCD. Similarly, delete the values ABCD from the stack. Now, initially, we want to insert a value into a stack by means of top. So now we are going to insert a value A into a stack. To insert a value into a stack, first of all, the top value will be incremented by 1. After increment the top value by 1, then the top value points to a position. Whatever the position that is pointed by a top, in that position, we are going to insert a value. Similarly, by the next time, if you want to insert a value B, then first increase the top value by 1. After increase the top value by 1, it points to a position. Whatever the position it points, in that position, we are going to insert a value into a stack. Similarly, by the next time, if you want to insert a value C, first increase the top value by 1. Then it points to a position. So in this particular position, we are inserting a value into a stack. Likewise for D also, which indicates for every insertion into the stack, first increase the top value by 1. This is related to insertion. Similarly, now we just go to perform the deletion operation. To delete a value from the stack, which value is going to delete first means, as we already know, which inserted recently, that value is going to delete. Apart from programmatically, whatever the value that is pointed by a top, that value is going to delete first. Now here, top is pointed to D, so the D value will be deleted. After deleting the D value, then the top value is decremented by 1. Now, top is pointing to value C. Then again, by the next time, which value is going to delete means the top to is pointed to some particular value, that is C, that value is going to delete. So whatever the value that is pointed by top, that value is going to delete. Then the next value is going to delete is C. After deleting, again, top will be decremented by 1. Now it is pointing to B. That indicates the next value that is going to delete is B. Likewise, for every deletion, first the value will be deleted, then top value is decremented by 1. This is what actually the insertions and deletion operations related to a stack. Now, apart from insertion and deletion operations, what are the basic stack operations that we are going to perform? Basic stack operation that indicates what are the basic operations that we are performing on stack. Recently, we discussed how to insert a value into a stack and how to delete a value from a stack. That insertion of an element into a stack is referred by a word, that is push. Push is an operation which is meant to insert an item or element into a stack. Similarly, to delete an item from a stack, there is one more operation which is referred as pop operation. Pop is the operation which is meant to delete an item from stack. For insertion, we use the operation push, and for the deletion, we use the operation pop. Similarly, if we want to display what are the values in the stack, in order to display the values in the stack on the output screen, we use one more operation, that is nothing but traversal. Traversal is the operation which is meant to display the values on the output screen, the values that are stored in the stack on the output screen. Apart from these three operations, still we have two other operations. Those are nothing but is full and is empty. Is full or not. Is full or not, that indicates when you want to insert the element into the stack. First of all, we must check whether the stack is full or not. If stack is full, you are unable to insert a value into the stack. So to check whether stack is full or not, here we are using the operation named as is full or not. Similarly, there is one more operation named as is empty or not, which is meant to determine whether the stack is empty or not, which indicates to check whether the values are there in the stack or not. Why we are going to specify this condition means whenever you are going to delete an element from the stack, first of all, you must check whether the elements are there in the stack or not. So to check whether the elements are there in the stack or not, here we are using the operation that is empty operation, which is meant to check whether stack is empty or not. If stack is empty, then ultimately we are unable to perform the deletion operations. So these are all nothing but the different basic stack operations. Push is meant to insertion, pop is meant to delete, traversal is meant to display, is full or not is meant to check whether stack is full or not, is empty is meant to check whether stack is empty or not. So these are all nothing but different stack basic operations. Thank you.